Today's warm-up is a review of a distance formula problem. What is the distance formula?
Square root. Oh, no. Yeah, square root.
Yeah?
Squared.
Then you square this, okay? Then what?
Y2
Plus
minus
y2
y1
minus y1 squared.
And then a big square root. Okay, good. So, basically you just plug in what you know. So we're going to do 4 minus negative 2 squared plus 6 minus negative 5 squared square root. So that's going to give us 6 squared, which is 36. That's going to give us 11 squared, which is 121. What do you get when you add those together? 157. Square root 157. I can't think of anything that goes into that.
Isn't it fine?
Yeah, it might be. Unless something weird goes into it like 7 or 13 or something like that. But I'm good with that. Definitely no perfect squares go into it. 4, 9, 16, 25, any of those. Okay, any questions? All right, today we are starting section 10-2. It's all about parabolas. Now, we did parabolas back in the day. When was that? Probably October-ish. We're actually going to take another look at parabolas. We're going to go about it a different way, though. I'm going to give you a standard form, not the standard form you're used to, not the y equals ax squared plus bx plus c, a different standard form, and it makes graphing them a lot easier. We're also going to look at parabolas that open up to the left and the right, not just parabolas that open up and down. So it's kind of, like I said, a different approach on parabolas. All right, before we start talking about just parabolas, I want to introduce to you what's called a conic section. This whole chapter, chapter 10, is on conic sections. Conic sections are formed when you take a double cone and you slice it with a plane. So if you just slice the top, oops, hold on. My bad. So right here, when you just slice the top of a parabola, the top of one of the cones, that forms a parabola. So that's how a parabola is formed. We're also going to look at circles. So if you just slice one of them and, right across, that forms a circle. If you sort of tilt it, that's an ellipse. And then if you cut down the side, that's a hyperbola. So those are the 4 conic sections we're going to look at in this class. Kind of interesting. I think they're fun. Any questions? You're probably asking yourself, well, there's 4 conics. Which one is your favorite conic? What do you think? Mine's the parabola. Look, there's me in front of a parabola. Who wouldn't love a parabola? I know. We actually did this. This is the second time you're seeing these pictures, but I can't resist. They're so fun. So this is a real parabola that I went to. This is not a parabola. And students always say, well, what makes one a parabola and what makes one the other one not a parabola? This is why. I told you guys in the fall when I showed you those pictures, I'll tell you more about why one is and one is not. This is why. So the actual definition of a parabola is that it has this property that any point on the parabola is equidistant from the point called the focus. So there's a point inside the parabola called the focus, and then there's a line outside of the parabola called the directrix. Any point on this parabola is the same distance from this point and this line. So you can see in this drawing what this means. So another popular mistaken parabola is the arch. People think the arch is a parabola. The arch does not fit this qualification. There's no point in the middle and a line outside that is equidistant. So that's why some things look like parabolas. They're not. To truly be a parabola, it has to satisfy this property. Any questions? All right, so here's the kind of the meat of our lesson today. We're going to look at, like I said, 2 types of parabolas. Parabolas that open up or down. Those are the ones you're familiar with. This is the form we're going to be working with, and I would definitely write this down. So if the x squared or if the x is the variable that's squared, your parabola is going to open up or down. Now, I would also make a note if the p is the part that's being multiplied by 4 and being multiplied by the y. If p is greater than 0, your parabola opens up. The focus is at 0p. The directrix is at the line y equals negative p. So the key is to find the p. Once you find p, you can find the focus, and you can find the directrix, and you can graph it. If p is a negative number, or if p is less than 0, your parabola is going to open down. But these things are still both true. The focus is still at 0p. The directrix is still at y equals negative p. So those things have not changed. All right, this is the parabola that's going to be a little newer to you guys. When the y is the variable that's squared, it's going to be opening to one of the sides. If the p is positive, it's going to open right with a focus at p comma 0, directrix at x equals negative p. However, if your p is negative, now it's opening left, but the focus is still at p comma 0, the directrix is still at x equals negative p. So I'm going to write all these things over here on the sideboard just so we have some place to refer back to. I would suggest getting all of this in your notes. You could do it without the sketches, you could do it with the sketches. It's really up to you. As you guys are finishing up on this, I should also point out all the vertexes we're going to look at today are at 0, 0. But from what you guys know about graph transformations, that can move things up, down, left, right. But the basic examples, they're all just going to be at 0, 0 for our vertex. So that's your starting point. Questions? So, before we get into our actual examples, I just want to kind of show you one. So again, you can write it, you can just relax and watch, it's up to you. But we are always going to start with thinking about the standard form of the parabola. So, in this one, I have x squared equals 4py. That's the standard form of a parabola that's opening up or down. Let's put some real numbers in there. Let's put a 12 in. So if I say now that the equation is x squared equals 12y, what is p? 3. That means your focus is going to be at 0, 3. Since 3 is the p. It also means that the directrix is going to be at y equals negative p, which in this case is y equals negative 3. Once you have those three things, the vertex, the focus, and the directrix, you can draw your parabola. Just make sure as you're drawing it that you're sort of eyeballing how it would need to be shaped in order to be equidistant from the line that's the directrix and that focus the whole time. So if you made it real skinny, it would be a lot closer to this point than the directrix. If you made it too fat, it'd be too close to the directrix, not close enough to the focus. So just sort of eyeball it where it needs to be the same distance from each. Any questions on that one? All right, let's look at the same sort of example. What's the only difference now? It's the y squared. So how is this one going to open? Left or right. Let's put some real numbers in there and then make a decision. I'm going to use the 12 again. So if we had y squared equals 12x, basically the main thing you need to find out, what's your p? What would p be here? 3. It's 3 again. So now our focus is at 3, 0. It's always at p, 0. Now it's at 3, 0. And our directrix is at the line x equals negative p. So now our directrix is a vertical line and not a horizontal line. And then again, just fill it in. Once you know those two key features and the vertex, you are good to go.
What's the vertex?
The vertex on these is 0, 0,
Oh, okay.
unless there's some sort of transformation going on. Any questions?
Do you pick the any random p?
You have to figure out what P is. So here it's pretty easy, right? They don't give you P. They'll give you an equation, and you have to find the P. Once you find the P, it's pretty easy from there. Yes. All right, here's example 1. All right, so the first thing we want to do is find P. Well, I know that standard form is x squared equals 4py. So 4p is all in this spot of the 2, right? So I'm just going to put 4p equal to 2 to see what p has to be. Matt already said it. P is a half. Now, since there's obviously no transformations going on, I know that my vertex is going to be a 0, 0. Is this going to open up or down? Or left or right? It's going to open up. P is positive, and the x squared, or the x is the part that's squared. I see an x squared in it, so I know it's going to open up. That means that my focus is going to be above my vertex. So that would have to be at the point 0, 1/2. And the directrix is going to be below it. It's going to be a horizontal line, so I know it has to be a y equals. And it's going to be y equals negative 1/2. Now, the closer it all is, the skinnier the parabola. So you can see this one's a lot skinnier than the one where p was 3. A lot of times when we're graphing conics, students say, is that it? Yeah, that's it. You can do an XY chart if you want. You can find a bunch of points, use the axis of symmetry, or you can do it this way. This is all that I am requiring of you at this point. Any questions? All right, here is number 2. Which way will this open as you're writing it? What are you thinking? To the right. Good. I know it's to the right because the squared term is my y, so it's either left or right, and I don't see any negative signs, so p is going to be positive. All right, so I know that the 4p is equal to 16, so I can use that information to find my p. P here is 4. So if it's opening to the right, my focus needs to be over here 4 units. That's the point 4, 0. If this is the vertex, this is the focus, the directrix has to be down here somewhere. It's going to be a vertical line, so it's an x equals. It has to be 4 units away from the vertex, so it's going to be x equals negative 4. It's going to be a wider parabola in order to be equidistant from those 2 features. And that's all I need. Is this a function? No, why not? Vertical line test. Yes, so a lot of students feel sort of like this isn't right, but these are not functions. You're used to graphing functions. Everything you graph up until now probably passed the vertical line test. So don't be alarmed if you're not passing the vertical line test anymore. That is okay. Any questions? All right, here's number 3.
How many examples are there?
8, I think. The question is how many examples? I think there's 8. I think there's 4 graphs and 4 equations, but I might be wrong.
You have equations with this?
Mm-hmm. All right, which way is this going to open? Down. Good. X is the squared term, so I know it's up or down. I see a negative sign. That means my p is going to be a negative number, so it's going to open down. The negative 1/4 has to be equal to 4p, so in order to find p, I'm going to write that equation. When I solve for it, I actually get that P is negative 1/16. So that needs to be below my vertex. That would be at the point 0, negative 1/16. Basically, right on top of it. Just below it. Especially if you're using graph paper, it's probably pretty close. Directrix has to be the horizontal line on the other side, so that's going to be y equals positive 1/16. This is going to be really skinny. What are your questions on this one?
Wait,
This one. Sorry, my ID hit my button. Any questions?
will you take off like a lot of points for how skinny your cabin may be?
All right, here is number 4. Which way is this one going to open? Left. I know it's going to be either left or right because the y equals. I see a negative, so I know it's going to be left. I need to figure out what p is, though. That negative 4 equals our 4p. So p is going to be negative 1. So in order for this to open left, my focus needs to be to the left. That's the point negative 1, 0. My directrix is going to be a vertical line in this case. It's going to be 1 unit in the other direction. So that is the line x equals positive 1. And then you can draw it in. What questions do you guys have? All right, next we're going to look at basically the same type of problem in reverse. The directions say that the vertex is at 0, 0, and the focus is at this given point. So we kind of have to think through what's going on here. If the focus is at 0, 1, that's above the vertex, right? So which way is it opening? Up. So we're going to start with the equation that has the x squared. What does 1 equal? In this equation, 1 would be the p. So just plug it in for the p. Simplify, that's your equation. X squared equals 4y. All right, for number 6, again, your vertex is at 0, 0. Negative 1/2, so that would be a focus to the left of the vertex. So what's our equation going to look like?
Y.
The y squared. Good. Put that negative 1/2 in for your p and simplify. Anyone know? Four times negative 1/2 was the question. Negative 2, thank you. Now, as we're working through these, you're probably like, oh, these equations seem simple, but you're going to get lots of equations every day. Every conic has a different equation in various forms, depending on which way it's opening and other features like that. So I have told you guys I will let you use a note card on quizzes and tests. If you want to start getting that ready as we go, that might be a good idea. So maybe after today's lesson, grab a note card, write down all these things you've learned about parabolas today. And then day by day you can fill your note card and then use it on your quiz. You have a quiz next Tuesday, so you can start preparing for that. Just a standard note card would be fine. Front and back is fine. All right, any questions 5 and 6? All right, we've got 2 more. And then we're done. So again, the vertex here is at 0, 0. Now my focus is at -2. So -2, 0 is 2 units to the left of the vertex. So which equation am I going to use? The y squared. Good. And then you're just replacing the p with that p value you were given. This is p. Put it right here. And simplify. And last one for the day. How is 8 going to look? What's it going to look like? Yeah, it's going to be an x squared because I know that this focus is above the vertex. You go side to side 0, you go up 1/4. So that's just right above the vertex. So I need the x to be the squared term. And I'm going to replace p with 1/4. That gives me x squared equals y. What are your questions about parabolas? My favorite conic. I don't feel like you share my enthusiasm for parabolas.
No, we don't.
Okay, maybe someday. All right, here's your homework. It's only odds. There are some graphs. However, I think graphing conics is easier just sketching a graph. I don't find graph paper super useful on these. If you want graph paper, though, just let me know and I'll print you some. If not, I would just do some sketches. Let me know if you guys have any questions.